Shift is brought to you by CCC. ADAS-equipped vehicles are not difficult to find, but what do drivers really think? Are they sought during the buying process? Turned off? Are there opportunities to create positive customer experiences after damage? For these answers and more, visit cccis.com/ADAS-perspectives.
Hi, everybody. Welcome to Shift, a podcast about mobility. I'm your host, Pete Bigelow.
Hi, everybody. It's Leslie Allen, and welcome to the show.
Joining us on the podcast today is Angus Pacala, the CEO of Ouster LiDAR. Leslie, LiDAR, a timely topic these days.
It is a timely topic. You can see right through that one, Pete. So I know that you recently got a chance to examine some trends in LiDAR. I mean, there seem to be, and I think we even point that out during our conversation with Angus, you need a scorecard to keep up with all of these LiDAR companies that are popping up. And you actually did something of a scorecard for Automotive News. Can you tell us, just from that experience and from that research, what kinds of trends are you seeing when it comes to LiDAR?
You know, I think the big one is one that started a few years ago at CES, where we started hearing about LiDAR trickling down into driver assist systems from systems that had been fully autonomous. And that trend is sort of in full force now. If we caught a glimpse of it 2 years ago, I think the big news of the day is that LiDAR is kind of proliferating and will proliferate in the next few years at the driver assist level. And that will help establish volume that drives down the price. That's the other kind of key point, I think, is the price for simple LiDAR solutions, let's call them right now, is sub $500 a unit. So those would probably be the two big things that I see right now. And I'm sure Angus will enlighten us further. But that, yes, Leslie, to your point, that was a big project that I worked on a few weeks ago where, we looked at maybe a dozen LiDAR companies and what specifically they're up to these days. And our listeners can find that on Autonews. Another big project from Automotive News, we'd be remiss if we didn't mention it today, Leslie, is the latest Shift magazine is out. What can you tell us about that?
Well, in the latest Shift magazine, which publishes on Monday, if you're listening to this on Monday, that'd be great. It's our magazine comes bundled with Automotive News, and it's also available on the web, autonews.com/shift. We are looking at 5G, and a lot of these companies they seem to be super jazzed about 5th generation wireless. It was really a fun project to learn about what possibilities are out there for using 5G in the car, using 5G for safety purposes on the road, and also just some of the inside story about how these telecoms are working hard and jostling for position and being able to set up these 5G networks across the U.S. It was pretty fascinating. So I hope you get a chance to check it out. And I know, Pete, you did a few stories for that as well.
Well, let me ask you this, Leslie, is from your experience in leading us through this issue, is 5G for ultimately watching cat videos in our car and entertainment purposes, or what does it bring to safety or other aspects of automotive and transportation?
Well, when you think about safety, automatically you think of C-V2X, which of course is cellular vehicle to everything technology. That is something that has been discussed over the years, and now we're actually going to see a way to enable this to happen more quickly with a higher speed network that allows companies to utilize the benefits of mobile edge computing and really kind of I know you did a story on this, Pete, offload some of that computing task from the vehicle itself to the edge of the network, close to the vehicle, but not on the vehicle. And so those are some of the things that we explore. We also explore the use of 5G for in-vehicle entertainment, the cat videos, like you mentioned, or whether it could be augmented reality in the vehicle, high definition mapping or over-the-air updates. There's so much that is enabled by this technology.
Yeah, maybe one of the things that I'll mention, Leslie, and maybe it pulls together, is there's a lot of LiDAR companies working in the smart city space, offering sensor inputs from intersections that kind of feed into that V2X environment that is now enhanced with 5G. So maybe Angus can tell us a little bit about that and much more about the LiDAR business right now and where Ouster is at these days. So without further ado, let's go to our conversation with Angus Pacala from Ouster. Angus, great to have you on the podcast today. Thanks for joining us.
Thanks, Pete. It's great to be here.
For listeners who may be unfamiliar, just give us a quick intro to Ouster and kind of where Ouster fits into the crowded LiDAR field.
Yeah, so Ouster is the first digital LiDAR company. So we are a manufacturer of high-performance, all-weather, safety-critical LiDAR sensors. And we founded the company around this innovative digital LiDAR technology. And that sets it apart from the analog technology that has dominated the industry really since the founding of LiDAR technology all the way back in the 50s. And the core premise here is that we are integrating all of the complexity of these purpose-built analog systems that are composed of hundreds or thousands of discrete off-the-shelf parts into a single CMOS digital chip. So it's reduction in complexity, increase in performance, and improvement in the economics of the entire system by integrating all that complexity onto a silicon chip. And that's really the playbook of Silicon Valley for the last 60 years. And so we're just kind of following a long line of companies that have adopted the silicon playbook to dominate kind of historically analog industries, whether it's CPUs, GPUs, telecom infrastructure, digital cameras, or now digital LiDAR sensors.
Playing on that history, maybe I'll take a quick detour here, but what is the history of LiDAR going back to the 50s or 60s, like you mentioned? I think for many people, it starts with the DARPA challenges. So what was LiDAR being used for in the decades before that, long before autonomous vehicles came along?
Yeah, I think so. The principle of LiDAR is very similar to radar or sonar or even echolocation. So once radar came around in World War II, I think it was relatively quickly posited that you could do the same thing with light. And the idea here is emit some electromagnetic radiation, whether it's light or radio waves, time how long it takes for that radiation to bounce off an object, and you'll know the distance to that object. And that's the same thing bats do with ultrasonic noise, right? Echolocation. And so in the 1950s, the first lasers were invented. And that was the missing link to be able to build the very first airborne LiDAR sensors. And I think for the next basically 50 years, 40 or 50 years, it was mostly a technology used in defense, airborne systems for surveying and things like that. And but then in the 90s, LiDAR started to become a safety critical sensor in the industrial sector, still based on kind of the same analog technology that had been used all through, since the 1950s. And then around in the early 2000s, the DARPA Grand Challenge came along, and these industrial LiDAR sensors built for kind of safety critical applications in industrial manufacturing processes were adopted by teams to try to drive cars around the desert. And that spawned this kind of new opportunity for LiDAR sensors to become the eyes, the safety critical eyes of autonomy in general. And, that's another big pillar for Ouster, and the differentiator is just, our view is that autonomy is this very broad trend that spans many, many different verticals, and everything that moves or watches something that moves can benefit from digital LiDAR sensors that can perceive the environment far better than a camera or a radar alone. And that's what we're building for, is really this broader autonomy space that was in some ways all started back with the Grand Challenge.
It's funny because you seem to be making the case that LiDAR is going to proliferate, yet you've said before that in just a few years, there's only going to be 3 to 5 LiDAR companies left. And, right now you need a scorecard to keep track of all the different entrants and where they fit in. So why such a sharp decline, and what are you doing to kind of ensure that Ouster is one of those survivors?
Yeah, that's a great question. So there are a lot of LiDAR companies today, and that is any new industry, any new opportunity. It's like the gold rush, right? Thousands, tens of thousands of people all rush in to try to capture a new opportunity. And that's the sign of an immature industry. The sign of a mature industry, especially in semiconductors, is having 3 to 5 players, right, that have captured the majority or significant portions of overall market share. And that's just if you just look at semiconductor industries like CPUs or GPUs or telecom switching infrastructure, 3 to 5 players, pretty good kind of rule of thumb for where this should end up. Now, what's unique about LiDAR is that I fully believe that there will be consolidation and there will be 3 to 5 players that win out. But in LiDAR, we've had a number of companies go public and pull on huge amounts of money. And so they may be able to exist with very little market share, but just deep cash reserves as almost zombie-esque companies for years and years and years. And so it may appear that there are 10, 20 odd players in the market kind of existing as these zombie-like entities, but when in reality, they're shipping almost no product and maybe have de minimis market share. And then, how does Ouster win? It goes back to the technology. Digital LiDAR, digital dominates. And that's true across industries going back 60 years.
So we have all of these zombie companies, as you mentioned. So how will they disappear? I mean, are we talking about mergers? Are they going to merge into other companies or just simply fall by the wayside?
So there's the companies that have gone public in the last year, which I think are the ones they pulled on significant funding, and they're going to be the zombie companies. It's difficult to incentivize them to merge potentially with other companies. I think they may stay on their own for a very long time. But there's also a large number of non-public LiDAR companies that are even earlier. And there's many more of them. There's tens, maybe 50 odd companies all kind of chasing this opportunity in LiDAR. And those, I think, are probably more ripe for consolidation and mergers, just because they don't have the cash reserves. Those companies probably won't be zombie companies. They'll be acquisition targets.
Out of all of these companies that are jostling for space in this field, how many of them are direct competitors for you in terms of digital LiDAR? And so how unique basically is Ouster in this field?
Yeah, we're the inventors of digital LiDAR. We're the first movers in the space. We're the only company that right now has this VCSEL SPAD-based architecture. SPAD is the CMOS digital side, VCSELs are the laser. We're the only company in the space that's currently selling these products. So, it's really important to be a first mover in semiconductors. You get exclusive access to partners and first mover advantage given the long design cycles. But I do expect that we'll have competitors in digital LiDAR long term. It's inevitable. I think there will be far more digital LiDAR companies that are in that 3 to 5. The 3 to 5 winners long term will be dominated probably by digital LiDAR companies. My job is to make sure that we're the biggest of all of them. But I do expect that we will have digital LiDAR competitors at some point.
Angus, using that first mover advantage, I know that Ouster has shipped more than 6,000 LiDAR sensors at this point. Is that the first mover advantage? And what is your production manufacturing strategy and footprint at this point?
Yeah, the first mover advantage, you could think about it as unit volume, but it's more that we're multiple generations of our silicon and our product. We're multiple generations into this cycle. So we released our first products in 2018, and we still don't have competitors in this type of technology. And so that's a 4-year head start right there, or excuse me, a 3-year head start right there. And that alone, that means that we have just that much more maturity in our silicon architecture and our manufacturing systems. In the conversations we're having with customers, we have over 600 customers today in mid 2021, and that's significantly more than most of our competitors. And so, getting to market, locking in customers, and also locking in technology partners on the product roadmap side is really, really critical because our suppliers want to work with the leading companies, and so success breeds success in that sense.
Obviously, on the Shift podcast here, we're pretty focused on transportation, but I know that you are involved in lots of different sectors, from smart cities to industrial applications, et cetera. Can you give us an idea of what are all the different sectors you are providing LiDAR for, and more so, like, what's the philosophy behind that diversification? Is that something that you're purposely looking for these different streams and not counting on one versus the other?
Yeah. So when I think about Ouster and what makes us special, there are three pillars. The first is digital LiDAR. The second is our diversification across industries, which unlocks a bigger TAM. And then the third is actually our ability to execute, which we can talk about. But that middle bucket is so important because that there is a much larger market here for autonomy and sensor technologies that fuel autonomy across industries. I truly mean everything that moves, that flies, that rolls, that walks, that looks at stuff that's moving and trying to monitor the environment. Those are systems that can benefit from high performance digital LiDAR sensors. In the same way that there's been this revolution in digital cameras, and that the overall TAM for imaging technology fundamentally shifted when digital cameras became a commercial, viable product in the early 2000s. That same shift is happening with digital LiDAR, and it's super exciting. And so, it's fundamentally, we want to be going after the biggest market possible, and that means that you have to play across markets. So those four markets: it's robotics, industrials, smart infrastructure, and of course automotive. The challenge is, building products that apply across those industries, and that's what Ouster has been able to do. That's what digital products, or one of the things that's special about digital products, is that they can hit the specs and the affordability that's required across industries.
How do you build something that's scalable across the industries? And thinking like automotive and transportation is kind of particularly more difficult, perhaps because it has to be automotive grade for safety critical applications. Does that present the challenge for Ouster or for anybody trying to hit all these different verticals?
Yeah, and this is an area I love to talk about because it's not actually quite what people expect. So I said LiDAR sensors started showing up in the 90s in safety critical industrial applications. That was one of the first major kind of deployments of the technology outside of defense. And there is now today almost $1 billion market for industrial LiDAR sensors that are used on mining equipment and manufacturing process equipment and forklifts and all this stuff to make that work more efficient and safer. And so there's this immense, and so those are all safety critical, challenging applications that in many cases have to be more stringent in terms of their quality and their lifetime performance and their environmental performance than even automotive. When a mine in Siberia or in Australia can be blisteringly hot, incredibly cold. Debris can be falling on the trucks that we're operating on, and that's more challenging than automotive. So automotive is absolutely challenging. I have a lot of respect for the automotive industry, but the functional safety requirements exist outside of automotive as well. And that's really cool. There are synergies that we can take advantage of where we build to the superset of functional safety requirements that span these industries.
I'd like to shift gears for just a moment and ask you about your corporate philosophy, basically. You've been trading publicly now for about 5-6 months. And I'd like you to just walk us through your decision to go through the SPAC route versus, say, a traditional IPO.
Sure. Yeah. And this is a question I get asked a lot because everyone wants to make sense of what's going on with SPACs. And the overarching thing, first of all, I'm incredibly thankful that we went the SPAC route. It's been a great option for Ouster. We've gotten an immense amount of exposure, credibility, and of course funding to fuel our ongoing success. But about this time last year, we had to raise around $300 million, either privately or through public markets. And the SPACs were a great vehicle to make that raise and to do it potentially faster and with all these benefits around visibility and credibility of a public company than going the private funding route. And so it really was just this practical, let's weigh these two options. One is faster and gives us more visibility, and it's just this kind of unique point in time to take advantage of. And so that's the route we went. It was a data-driven decision, I guess. But it is a little bit of a double-edged sword, which is, I think, why I get asked this all the time, because there's a very wide range in the quality of companies that have gone the SPAC route. And this is something I'm pretty passionate about, because I feel that Ouster is on the far end of kind of real company, hundreds of customers, positive gross margins, outsourced manufacturing, things that really are proof points in the market that, we're not talking about hypothetical things that are going to happen in 5 years. We really want to be the company that has come in and build a credible and real company day one.
So what's it like having to answer to shareholders now? I mean, has that been a big change for you in terms of your day-to-day work and how you approach people? I've always had to talk. You're talking to investors one way or another. If you're starting companies, and they're either private investors or public. Now it's a different interaction. There's lots more process and regulation around how we interact with investors, and that's been a really interesting learning experience. I also I have a lot of respect after talking to investors and analysts for the last 5-6 odd months. There's a lot of really kind of good research that is done in order to make these investments, and that it was an appreciation I never really had. Just always having worked at private companies. So I think it's been a great and really interesting learning experience.
Angus, I'm curious, you mentioned your 600 plus customers, I think, that you're working with. One of the big ones that sticks out to me is the one that you recently announced with Plus, the automated trucking company. And I kind of think of trucking as a, one of the first practical waves of autonomy that we'll see on roads. How did that partnership come about, and what is the potential you see with Plus in particular, and maybe trucking in general?
Yeah, so automated trucking is just plain cool. The trucks are huge; they're doing really productive work. So much of the United States freight is moved by these vehicles, so it's a really cool application. And Plus, we've had a pretty long relationship with Plus. They've been testing our sensors for well over, I think, almost over 2 years now. So they started by doing nearly a year long on-road test of our sensors head-to-head with a number of other LiDAR sensors. And this gives you a little bit of a sneak peek on how you win customers. And they were looking at things like durability and performance across a wide range of conditions and a long duration of time. And at the end of that, the affordability came into the mix, as they're looking at affordability, durability, lifetime performance, and then just raw performance. And we stood apart. And that's just kind of the benefit of the digital technology. It's more robust, it's more affordable, and it's more performant. And so now we're doing, I think, the world's largest kind of binding deployment of LiDAR sensors, certainly in robot trucking, but I think in kind of all of automotive. And that's 1,000 trucks, 2,000 sensors, so two sensors per truck. And they're working with end customers like Amazon on this. So it's a really big deal. And then in terms of kind of what's driving this, one of the things that's exciting about robot trucking is just that there's this near-term opportunity to get the technology into production because it's a retrofit. You don't have to build the technology into the trucks at the OEM manufacturer. These trucks are owned and operated by large companies that understand that, want to invest in their fleets and make them more productive and more cost effective. And so they can retrofit. And that's what we're doing with Plus. It's what's happening with a lot of our other robot trucking customers. And it just means we can get the technology immediately on the road. And then the other dynamic that's driving robot trucking is that the ROI is so clear. I mean, you can save on fuel, on safety, and on efficiency, kind of uptime of the fleet. And if you save 1 to 2% even on the overall costs of running a 10,000 vehicle fleet, that is so immensely valuable for customers like Amazon or Walmart or any of these big distribution chains. And so that sophistication of the customer and the understanding of like 1 or 2 percentage points of value gain is also driving adoption now versus 5 years from now.
We're going to take a short break from our conversation with Angus for a word from our sponsor.
As OEMs innovate and consider how and when to offer sophisticated ADAS to their drivers, it's not clear how consumers will respond. Research indicates consumers remain skeptical of this emerging technology. Understanding barriers to widespread acceptance and adoption is critical for OEMs to not outpace demand. Opportunities exist to educate drivers on how these features can improve their time behind the wheel. And when complex ADAS features are damaged, a simplified path to a positive repair experience can build customer trust and satisfaction that help drivers remain in the OEM family and get back on the road faster. Find this research, analysis, and more at cccis.com/ADAS perspectives.
And now back to our conversation with Angus Pacala. So you've hit on kind of cost as a big differentiator when customers are choosing between LiDAR companies. And we hear about range, resolution. The one that's underappreciated to me, and I'm hoping you can shed some light on, is power consumption. Where does that fit into the mix? How often do you hear about that being kind of a key priority? And how much power do your sensors draw exactly?
Yeah, and so this touches on this idea that there are many different facets to performance. It's not just range or resolution or field of view or power draw. It's actually all of those things for a lot of customers that matter. And our goal is to be the best across every one of those metrics. And you can just look at digital cameras to know that that's actually possible. A digital camera is the lowest power, most durable, highest resolution, best imaging technology, CMOS digital cameras specifically. And they're so good that you can build one that goes on a drone that's flying around Mars. And that same technology is working in your iPhone and is working in your car and is working in, a telescope that's, imaging the stars. And so it's really amazing how flexible and capable digital technology can be. And so our goal is to be the best in class across all metrics. And so power draw, and that's how we can play across industries, right? Flexibility, best in class specs across all these capabilities means that we can draw the most customers. So we have the most power efficient sensors on the market. Power efficiency measured as power in versus data points out is really how we measure it. So power per data point. So best in class there, the smallest sensors on the market, lightest weight, highest resolution, and widest field of view. Kind of that complete, and then most reliable. And we have a standard 2-year warranty. So the goal is to be best across all axes, and incorporating everything onto a single silicon chip is really the key to making that all happen.
Now, where do you see the automotive field turning when it comes to LiDAR? I mean, a lot of people are saying there should be more focus on level 2 technology, ADAS in particular, and others are focusing most of their efforts on level 4 and robotaxis. I'd be curious to see what you think, where you think the industry is going to go.
I think this is one of the coolest things that's happening in auto tech right now. Obviously, EVs is really, really interesting. But then this battle between established, tier 1 and OEMs that are building L2 systems and new players coming in and trying to race to L4 systems. And they're trying to see who's gonna get there first and hypothetically dominate the other is super fascinating. I've set up Ouster so that we don't have to predict who's going to win, right? We're trying to sell, and we are selling LiDAR sensors to both these applications. And I don't want to be put in the position where I have to make some sort of existential bet on one or the other and be wrong. It's better to be, selling the pickaxes in the gold rush, so to speak. So, but I think it's been amazing to see how it's established. Automotive is way harder than something like smartphones and the cell phone industry and consumer electronics. And I think if you asked people a decade ago, even myself, I would have said, oh, automakers are going to be caught flat-footed, tech companies are going to roll in and dominate L4. And that's just not the case. Automotive is so much harder, the state of criticality of it, the diversity of kind of situations in the environment. And so I love that it actually really is this unknowns and I like that people are building, there's more appreciation in Silicon Valley after 10 years of trying to build automotive technology for how sophisticated automakers are in building safe and affordable cars.
Yeah, I recently saw a program where you pointed out that there were some differences between working with automotive customers versus mobility customers. Can you enlighten us a little bit on that? I thought that was a fascinating discussion.
Yeah, and this is all couched in there's reasons for the differences, and that's what we're talking about. So, and each is trying to be a little bit. So the new mobility customers are trying to be more like automakers, and the automakers are trying to be more nimble like the new mobility players. And you can see that happening when you interact with them. So, there's so much upfront work done by automakers to make sure that they're not going down some wild goose chase with the technology. But I think that's actually and so that naturally makes there's so much information requested, and the quoting process and the diligence process is incredibly heavy from automakers or tier ones when you're interacting with them, to the point where you're like, wow, I've never interacted with a customer set that is so almost demanding. But there's a reason for it, because they don't want to make billion-dollar mistakes on rolling out technology that doesn't work and that takes 5 years for them to develop. And then on the other side, there's mobility players where they're willing to try things immediately. When you could sell them a product and they'll have it on their vehicle for testing in the next day maybe, and they're willing to deploy a pilot fleet with drivers in the loop, mind you. So this isn't like fully automated technology, and that's the big caveat. But they're willing to kind of get the technology out, see what works, and iterate and iterate and iterate. But this is all couched in the fact that everything has driver in the seat really at this point. So they're more open to not meeting every spec that is absolutely required, and kind of working to see the technology progress and giving kind of the benefit of the doubt almost to customers or to suppliers like us in some cases.
Angus, this is decidedly a West Coast question, but has the semiconductor shortage impacted Ouster and or, to the best of your view, the LiDAR industry in general?
I know for a fact that this shortage is affecting the LiDAR industry in general. As it pertains to Ouster, we've done a really good job of securing the supply we need to ship to our customers this year. But it's something that I talk about every day with investors, every day with analysts, and every day with our team internally. And so, we are making sure that that supply outstrips demand and that it stays that way for the year. Since it is kind of this unprecedented situation. And it does kind of go to, puts things in perspective when the world just can't produce enough of something that everyone needs. It definitely makes me feel a little smaller.
Changing gears a little bit, you mentioned earlier the DARPA challenge, and if I remember correctly, that's kind of I forget if you were already at Stanford at that point or maybe even beforehand, but that just watching that from afar seemed to have a big impact on your worldview and what you wanted to spend your time working on. Is that right? And how did you get into this?
Yeah, that's absolutely right. So the Nova Special, the DARPA Grand Challenge, the Great Robot Race, came out in 2006, and it was just incredibly captivating for me. I think partially because I'm a big Baja 1000 fan, and I just love off-road desert racing. And then to see these big, powerful robots doing it, and the engineer, it's just inspiring for the engineering me. And so, and again, what I saw was industrial LiDAR sensors being repurposed to drive those vehicles. And some of the best vehicles in the race used LiDAR sensors really, really significantly. And so that was this jumping off point. I was interested in the autonomy technology in general because of that, and then LiDAR specifically because it was the technology that was the least mature, but that clearly had the most potential to impact the end results.
And so, did you go to Stanford then, like with light? You not to use this terrible pun, but were you laser focused on LiDAR from that very start for that exact reason then, or did you kind of fall into it further?
I did actually. Maybe not laser focused on that as the only thing, but I did write my essay, my Stanford essay about the DARPA Grand Challenge, as it so turned out. And so I was very interested. So actually, for people listening, Stanford won the 2006 DARPA Grand Challenge. Sergey Brin's group there. Oh, excuse me, not Sergey Brin. Oh gosh, I'm going to blow over the name.
Sebastian Thrun.
Yeah, Sebastian Thrun. Excuse me. Yeah, Sergey Brin. Then Google went on to work with Sebastian Thrun. So Stanford won it, and it was really interesting to go to the place where that won the event. And then out of school, actually my degrees were in mechanical engineering, then mechatronics. Mechatronics really is about building robotic systems, complex electromechanical, sensor-laden systems that rely heavily on software. And that's what an autonomous vehicle is. And so then I had kind of the training to go out into industry and to start work in LiDAR.
And so now, Angus, you have this vision, as you've expressed to us, of putting LiDAR on every moving object in some way or another. And is there a certain price point where that will be possible?
Yeah, absolutely. I think that the price point. I mean, you can look to digital cameras. I guess that's the really good example. There are digital cameras that span like 50-cent digital cameras, and that are almost disposable, all the way up to multi-$1,000 digital cameras, and they all have their use. And we are playing and intend to continue to play in the $100+ regime, 100 all the way up to $10,000 regime for digital LiDAR sensors. That's where the safety criticality is. That's where the outdoor challenging, adverse weather condition environments are. That's where all the really sophisticated customers are. And that's where I think you can improve quality of life the most. So safety criticality, like stopping accidents, stopping workplace injuries, improving traffic and the intelligence of improving roadway safety. The Vision Zero project, reduce having no roadway or pedestrian accidents in this country. That all is where $100 spanning up to $10,000 digital LiDAR sensors will be playing. And so that's where we're going to play. But there's going to be, and already are actually, some consumer grade LiDAR sensors that will fill that $100 to $10 spot. And the iPhone 12 has a LiDAR sensor.
Angus, it's been great having you on the podcast today. I know we've jumped around a bit, hit a lot of different topics. Any closing thoughts or anything that we missed?
No, I mean, I want to open people's eyes to the broader opportunity here. That's like one of the main messages I want to get across. This is a really interesting space that spans many verticals. It's a lot of the same technology that there's been investment in automotive that's now propagated to all these other verticals, and it's going to make all of those verticals and applications more efficient, safer, and improve quality of life.
We touched on this a little bit before, but is there any one of those verticals that you see as the one with like the most near-term growth potential that you see, let's say by like 2025 is going to be the one that's, have grown the fastest over these next 3 or 4 years?
I don't know. I think it's a toss-up. That all of these verticals are growing quickly for different reasons, but by 2025, can we have a large percentage of the intersections in North America deployed with intelligent sensors that improve traffic and make sure that you don't get hit crossing the road? That's an immense opportunity. But likewise, maybe there will be hundreds of thousands of delivery robots rolling around delivering new packages in that time frame as well, and that could be an equal or greater opportunity as well. So I'm not here to be the oracle, but I know that they're both amazing opportunities.
Well, thank you again, Angus. Great to talk with you, and look forward to hearing more from you and Ouster going forward.
Yeah, thanks, Pete, and thanks, Leslie. This is great.
Thanks so much to Angus for joining us on the podcast today. Leslie, enjoyed that one. Felt like I learned a lot about where Ouster sits in this crowded field.
Certainly, and his whole vision of having pretty much everything that moves be enabled by LiDAR. That's pretty fascinating. And it will be interesting to see whether their strategy of focusing on digital LiDAR will help them stand out in the crowd.
That's right. We'll have to have Angus back on at some point here in a year or two to see how those plans come together. More in the short term, Leslie, we should let people know that we have 2 podcasts coming out. One is directly related to our 5G magazine issue that we previously mentioned. Do you want to give us some details on who our guest is on the 5G topic?
Well, just a brief preview. We are going to be speaking to 2 executives from a company called Umlaut. And it's just like the punctuation mark. Umlaut is a company that specializes in engineering and consulting, and they were recently acquired by Accenture. They are going to be talking to us about 5G. They do lots of studies, lots of benchmarking studies on 5G. If you hear a commercial where somebody says, we have the most reliable 5G network, blah, 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 a lot of times they're citing data from this company. So we're going to talk to them not only about 5G, but we're also going to touch on a new study that they've done on digital cockpits and cars. So that should be pretty interesting. And after that, Pete, can you tell us about our next guest?
Sure thing. In our regular weekly shift podcast on next Monday, we're talking to Claire Jones, the Chief Operating Officer of micro-location company What 3 Words. I think that's going to be a topic that we've not explored yet, but should prove to be very interesting. So looking forward to it. Hope our listeners join us again next week. Thanks to our producer, Eric Jones, as always. And that's it for today.